Bismillahirrahmanirrahim. Welcome to my channel Learn Math with Sayyid Ali. So we will be continuing our topic trigonometric expressions and trigonometric identities, right? So here in this lecture, trigonometric expressions simplification strategies. So we have some type of the trigonometric expressions where we have to use expansion or expand. So we expand them, right? Expand means we really multiply them. If we have two brackets, we have to multiply them to get to the result. And then convert it to the sine or cos, because we have some of the identities which are proven, and we make use of those identities. And number 3 is we should be very good in fractions, because every time we have to do some fractions, and we did in lecture 2 as well some of the fractions. And one of my student has asked me about fractions, so we will deal with that in a separate class. So let's take them, like what is proof strategies, what we can do. So one thing is factor, right? We have to be very good, and we have to see that how we can factor the given expression, right? Factor is the important thing. And then as we did expand, so we know that how to expand it, or real multiplication or real division, right? Then what we have to do, we have to cancellation. Cancellation means whatever is common or cancelable, we cut that, right? Identical units or identical things will get cancelled. Identical things get cancelled, right? So we have to reach to a certain point that if we have something in numerator and denominator common, we have to cancel that, or if we have plus something and minus something, we have to cancel that too. So these are cancellation strategies. Then we have convert sine theta or cos theta, means we have to make use of cos and sine strategies, right? We know that all those strategies, right? Sine squared theta, the most important is sine squared theta plus cos squared theta is equals to 1. And then we make use of division when given fraction is, right? If certain thing is in division, we know that division can be changed to multiplication, can be changed to multiplication by flipping, right? So we have to make use of all of these things while solving the trigonometric identities. Or we can say we do all other division, subtraction, this and this, everything, right? So all four mode of operations. All four mode of operations are addition, subtractions. So there are rules, right? So we use everything what we have learned so far. For example, if we have question simplify, what is the question asking is only simplify, because this is simplification strategies, right? So what question is giving here, 1 minus sine x times 1 plus sine x, right? And question is just saying that simplify, right? So what we have to do, we have to expand it, right? Like 1 will be multiplying with the whole bracket first, like 1 times, as we did in algebra, right? Simple algebra, a plus b, a minus b thingy or something like that. So minus sine x will go and multiply it. So minus sine x multiply with the bracket 1 plus sine x, and then we are really multiplying them, 1 plus sine x minus sine x and minus sine square x, right? So now we can see that plus sine x and minus sine x get cancelled. So we are making use of all these things what we wrote here. Identical things get cancelled, right? With a plus sign or minus sign, they get cancelled, right? And we multiply them, right? And then what is left is 1 minus sine square x. And 1 minus sine square x can be written as cos square x, right? So this is my answer. I can say that I am not changing anything in my given question and I arrived at a simplified result of cos square x. So this was my first example. I can take another example, question 2. Hope you understand it, right? So what we are using here is simplification strategies, right? Making use of all those identities which we learned in the lecture 1 and lecture 2. Now we are trying to solve these equations which are given, or expressions, trigonometric expressions which are given. 1 minus cos square x, this expression is given, right? And we have to solve it. What is this? Now we have to multiply. As we said that we have to really take advantage of those mathematical functions. So, this question is saying 1 minus cos x whole square. Whole square. Whole square means you can write it 2 times, right? So that means you can write it sine x as it is, whatever it is, wherever it is. But 1 minus cos x square means you can write it 2 times. 1 minus cos x and 1 minus cos x. As simple exponent function, x square means x times x. So 1 minus cos whole square means 1 minus cos x times 1 minus cos x, right? So we have to really multiply these 2 brackets now, right? So sine x is there, whatever it is. Now we have to expand this. How to multiply this? So 1 times this whole thing. So 1 times 1 is 1. 1 minus cos x, right? Minus cos x times 1 is minus cos x. And then cos x times cos x is plus cos square x. Hope you understand. This is real multiplication. 1 goes and multiply with 1, that is 1. 1 goes and multiply with minus cos x, minus cos x. Minus cos x multiplied by 1 is minus cos x. Minus minus plus cos x times cos x is cos square x, right? We can see here, so sine x is my outside the bracket. Sine x is still outside the bracket. And I have here 1 minus 2 cos x plus cos square x, right? 2 cos x plus cos square x. This is what I have. Sin x is outside. Now is the time to get sin x into the bracket. So if I take this thing inside, that will be sin x minus 2 sin x cos x plus cos square x sin x, right? So what we did, we get into the equation, we solve it, and when we expand it. So what we have is sin x minus 2 sin x cos x plus cos square sin x, right? You can substitute cos square x as 1 minus sin square x and get more out of it. So until you see something which is replaceable, you go and substitute for that value. Sin x cos x plus cos square x is 1 minus sin square x times sin x, right? So you have sin x minus 2 sin x cos x plus, you can say here, sin x minus sin cube x, right? Now you can add these two because they are similar, and that will be your final, where you can leave the equation. So you will say 2 sin x, so I'll write it here, 2 sin x minus 2 sin x cos x minus sin cube x. So what you have to do is you have to simplify and go on doing it, converting it into simplified cos and sin function. So 2 sin x, if you have something like, you can leave it here as well, cos square x, you can leave it here, or you can go further to leave it here. Both are correct. Let me check another question for you. Here, question number 3, and that is cos x plus 1 times cos x minus 1, right? You can use here a plus b, a minus b version of your algebra, but if you want to do real multiplication, you can also do that. So what is that? Cos x times cos x, which is cos square x. Cos x times minus 1 is minus cos x. 1 times cos x is plus cos x. Plus 1 minus 1 is minus 1. Plus cos x and minus cos x get cancelled. So you are left with cos square x minus 1. And cos square x minus 1 can be written as minus sin square x. So this is your answer. Hope you understand this. It's simple, but it's like a little bit tricky, right? So question number 4 is, let's say, what you can say about the question. You can have sin x cos x, right, divided by sin square x. So how to get, like if you want to take advantage of sin square x, you can write sin square x as sin x, right? So that means exponent rule applies here. So cos x divided by sin x and sin x, right? So one sin x got cancelled. What I am left with is cos x divided by sin x. And we learn in our lecture 1 and 2 that cos x over sin x is cot x, or I can write it 1 over tan x. Both way of writing is correct, right? So cot x or 1 over tan x is my answer. So you have to simplify it until the time you have nothing more can be done to the expression, and we have to factor it, we have to expand it, we have to use all the trigonometric identities which we have learned before. So this is a kind of just give it a practice. I will do one more lecture on this trigonometric identities, like lecture 4, and then I will be answering more questions which I receive, and I have a long queue for the questions from my students. So wait for your turn to see your solution onto the YouTube video. So subscribe to my channel, thumbs up, and if you like it, share it with your friends and family friends. Thank you for watching.